Suppose we take this 8.5 by 11 sheet of paper, and we're going to fold it We've got the same amount on either side, X on either side. Then what we have left is that 8.5 minus the 2x. Why 2x? Because it was x from either side. I'm going to fold this into a from two-dimensional into a three-dimensional object, and we want it to have a maximum cross-sectional area going this way. So we would want to maximize area as a function of x. And again, since it's going this way, now that x is a height, and we've got a base of 8.5 minus 2x. If we distribute, then we're looking at a quadratic function. I'm going to put that in descending order. Oh, x there. Being that that's a quadratic function, the graph is a parabola. Because a is negative, it opens down. So if we want to talk about getting the greatest area, then we're talking about finding the vertex of this quadratic and what x value would produce the maximum area, what is the maximum area. We don't have to complete the square on this. We can use the formula x equals negative b over 2a. So we're comparing this to ax squared plus bx plus c. C is 0. There's no constant term. We've got negative 8.5 over 2 times negative 2. Those negatives are going to cancel. And negative 8.5 divided by 4. I want to say 2.125, but I'm checking. Yes, 2.125. Okay. Now that would be in inches, because I'd mentioned that we're talking about 8.5 inches long here, and so x inches on either side. If we plug in 2.125 into any version of the quadratic function, then we'll get what the maximum area is. Times 2.125. Okay, that's going to be 4.25. 2.5 minus 4.25 is 4.25 again. So multiplying 2.125 by 4.25, we've got 9.03125 as the maximum area, and that's in square inches. Now, suppose that we want to know what depths x. So this 2.125 here was the depth once I folded up the paper. That was the depth that maximizes. We're not going to be able to go any higher than this. But what if we want to know what depths would allow at least a flow through there of 6 square inches? So let's see here. So part B, what depths allow at least 6 square inches? Actually, I'm going to change that so we can get some slightly nicer numbers. I'm going to go with 6.5. So we're looking for the quadratic function to be greater than or equal to 6.5. I've multiplied everything on both sides by -2, which is going to include switching the direction of the inequality symbol because we're multiplying and it's by a negative number. So if I add 12, we're looking to solve that inequality. And let's see, AC method, +4 and +12 multiplied together equals +48. But they have to add up to a negative. Let's see here. My mistake, since I switched it to a 6.5, it's going to be a -13. Add 13 to both sides. 4 times 13 is 52. And let's see if we can find a pair of numbers that also adds up to -17. $52, not divisible by 3, dividing by 4, 8, 13? Yep. So that's our pair. Use the AC method followed by grouping. So 4x squared minus 17x plus 15. I'm rewriting that as 4x squared minus 4x minus 13x plus 13. Factor out a 4x in the first group, leaving us x minus 1, and factor out a 13, negative 13, also giving us x minus 1 as the other factor of that group. So that's going to lead to x minus 1 as one factor of the left-hand side, and 4x minus 13 as the other factor. What's going to make this exactly equal to 0? Is x equals 1 inch, or (13/4), which should be 3.25 inches. Double checking that. 13 divided by 4. Yep. So now what I have to do is convince you that, in fact, in between there, we're going to have positives in this. There's another way I could be showing, but for speed purposes, since this is a parabola that opens down, if we're hitting exactly 6 at 1 inch, 6.5 square inches for a cross-sectional area, then at 1 or 3.25 inches, then because the parabola is opening down, we've got the vertex. What did we find? In between 2.125 inches was the depth that created the maximal cross-sectional area, and the y-coordinate of the vertex, 9.03125. At that horizontal line, the cross-sectional area is the 6.5 square inches. And so it's going to have to be in between, it's going to have to be above. So you're talking about any values for x that are between 1 and 3.25 inches will give us a solution to this inequality, therefore giving us a cross-sectional area greater than or equal to 6.5 square inches. Got one more example coming up shortly.